Hi everyone. So let's continue with subtopic 5.2 liquid. So here are the learning outcomes. You should be able to explain the properties of liquids such as in terms of shape, volume, surface tension, viscosity, compressibility and diffusion. Explain the vaporization process, condensation process, based on kinetic molecular theory and intermolecular forces. Define vapor pressure and boiling point. Explain the relationship between intermolecular forces and vapor pressure with boiling point. Let's have a look at the first properties, which is volume and shape. So for liquid, they will have fixed volume but not a fixed shape. Means if you have 50 ml of your liquid, if you pour them into a bowl, so your liquid will follow the shape of its container. Okay, so if you pour into a different container, let's say in a conical flask, so your liquid will follow the shape of the conical flask. Okay, the particles are arranged closely but not rigidly as compared to solid, but it is still held by a strong intermolecular forces, but it is not strong enough to hold the particles in a fixed position. So you can see particles or molecules in liquid, they can still move around freely, but if you compare to gas, particles in gases, they can move more freely compared to in liquid. So let's have a look in terms of compressibility. In liquid, the particles are packed closely together compared to gas. Therefore, you can see there is very little amount of space between them. Okay, so you can see here in liquid, they have very little space. Therefore, they are more difficult to be compressed compared to gas. So you can see if you want to compress liquid, it is almost impossible. Okay, but if you compress gas, you can compress and push the molecules or particles closer to one another. Right, so let's have a look at diffusion. So for diffusion rate in liquid, they are much lower compared to in gas. Why? This is because of molecules are closely packed compared to gases. Therefore, it will have lower kinetic energy compared to gases. And in addition, they will have stronger intermolecular forces between the molecules. So imagine, okay, you have water. Okay, so ini air, water. And then the blue color ni kamu imagine a coloured syrup. Okay, ataupun any colouring. So when you put a few drops of the colouring, so you can see it will slowly diffuse with the water molecule, and eventually your water will turn into blue color. Okay, so for diffusion, we also use this concept in biology, especially for transport. Okay, so the diffusion of solid transport is from high concentration region to the lower concentration region. Next is surface tension. It is defined by the amount of energy needed to stretch the surface of a liquid by unit area. So means akan ada tarikan lah between the molecules. The liquid molecule will experience intermolecular attractive forces between them in all direction by the neighboring molecules. So, let's say your molecules di bahagian tengah ini, dia akan experience attractive forces with all the molecules, the neighboring molecules around it. Okay, so let's say you have the molecule on the surface. Okay, macam ni. So the attractive forces is sideways, kiri, kanan dan downwards. Okay, but if you have the molecule in the middle, okay, let's say di bahagian tengah of the liquid, so around the neighboring molecules in all direction akan ada tarikan, attractive forces. And the importance of this surface tension, it allows this water strider untuk float on water, ataupun it is a explanation for why paperclip can float on water because of the surface tension. Okay, so for the surface tension, these intermolecular forces of attraction, they will pull the molecules into the liquid, so akan ada tarikan from all direction. Okay, it will cause the surface to stretch and tighten. So kalau dalam container, dia akan membuatkan permukaan di atas ni akan stretch dan rasa akan tegang lah. Okay, so that is why paperclip boleh float on water, water strider boleh float on water. Okay, because of that. The stronger the intermolecular forces means the higher the surface tension. Okay, ataupun it can also be used to explain why the water droplet ni dalam bentuk semi-sphere. Okay, bukan full sphere. Okay, because of the surface tension, so you can see kalau dekat surface hanya ada tarikan sideways dan downwards. Okay, so if the molecule is in the middle, so all it will has attractive forces in all direction. Okay, that is what hold the position ataupun shape of the water droplet. Okay, but when you have temperature increase, what happen here is, bila kamu increase the temperature, the intermolecular forces will become weaker. So maksudnya you break the intermolecular forces between them lah. Okay, therefore the surface tension will decrease. Okay, next is viscosity. Viscosity is the ability of the liquid to flow. Okay, untuk mengalir. The higher the viscosity of the liquid means the slower it flows. So maksudnya, contoh kita compare viscosity of honey, madu dan water. Both are liquid, right? The water molecule will flow faster compared to honey. This is because of the viscosity. Okay? And viscosity will decrease as you increase the temperature. Okay? Viscosity will depends on factor pertama. The first one is size of molecule. And the second factor is strength of intermolecular forces between the molecules. So for the first factor, the higher the molar mass means it will have the bigger the size lah. Means it will have more resistance for flowing. Okay, the bigger the size, the difficult lah untuk the liquid to flow. the higher the viscosity of the liquid. Okay, next factor is the strength of intermolecular forces between molecules. When you have stronger intermolecular forces, means it will have higher viscosity. Which is why when we increase the temperature or we give heat, okay, it will have enough energy to overcome the intermolecular forces. So that is why if we increase the temperature, the viscosity will decrease. Next, let's have a look at the vaporization process, or we call it as evaporation. It is a process which liquid particle with enough energy will escape the liquid surfaces and enter gas phase, or in simple word you can call it as liquid that will transform into gases. So you can see, highlightkan di sini, it is from the liquid surface. So means if you have liquid, only the particles or molecule at the surface yang akan evaporate first. So for the vaporization process, molecules in liquid, they can move freely. So each molecule will have kinetic energy. Some of them will have relatively high kinetic energy. So the molecule will collide with one another, and each collision will transfer the energy within the molecule. So some of them will have sufficient energy or enough energy so that they can overcome the attractive forces between the molecule that bind them, yang mengikat each of the molecule tu, and then the molecules will be loosened and be evaporated from liquid. They will change to gas. So vaporization process, the rate of vaporization depends on the surface area. So you know that the larger the surface area means the higher the chances of the molecule to escape the surface. As I mentioned before, it is the surface of the liquid. Okay, so if you have small beaker and with a basin of or a bowl of water. Okay, so the larger the surface area, the molecule on the surface, okay, will be easily evaporated. More molecules can be evaporated lah. Next, the factor is temperature. As the temperature increase, the total number of molecules with higher kinetic energy will also increases. Okay, means they will have enough energy to escape from the surface of the liquid, and thus the evaporation rate will also increase. So ingat balik just now I've mentioned the process. So if you have your, okay, so let's say you have your bekas, okay, and then your molecules, each of them will have kinetic energy. Okay, and then when they collide with each other, okay, they will transfer the kinetic energy from one to one another, and then slowly energy tu akan transferred ke the molecules or particle at the surface. Okay, so when this molecule at the surface have enough energy, therefore dia akan slowly freekan diri dia and change from liquid dia jadi gas. So it will escape Ini yang maksudnya escape the surface of the liquid tu. Okay, next factor is the intermolecular forces. So for the intermolecular forces, if you have weaker intermolecular forces, means the molecules are bind not too tight, means tidak terlalu kuat lah dia punya daya tarikan, means the evaporation rate akan jadi lebih tinggi because the easier for the molecules to break the attractive forces ataupun to overcome the intermolecular forces. Next, let's see the process of condensation. Okay, so when the molecules of liquid molecule, they change to vapor molecule, okay, but after some time, they will lose the kinetic energy because of the collision. Therefore, they do not have enough energy to remain as vapor molecules, and they will reach the surface of the liquid and trap again by the attractive forces. If they cannot overcome the attractive forces, therefore the vapor molecule will return as liquid molecule as the original. And this is the process, we call it as condensation. So means in your container, let's say ini adalah closed system. So when your molecules, okay, contoh liquid molecule, dia akan ini on the surface. Okay, when they have enough energy, so they akan slowly start to evaporate. Okay, as they change into vapor molecules, okay, if they have enough energy, they can remain lah as vapor molecule. But then if it's starting to lose dia punya kinetic energy, okay, let's say contohnya we change the temperature, okay, for some time dia akan start to lose the kinetic energy and then dia akan return back to the surface of the liquid. For the molecule that escape the surface of liquid, we refer them as vapor molecule. In an open system, vapor molecule will evaporate off and diffuse away. Okay, so maksudnya, if you have open system, so your vapor molecule dia akan evaporate. Contoh, ini liquid molecules on the surface. So bila dia start to evaporate, so dia akan jadi vapor molecules. Ni vapor. So if in open system, it will evaporate and diffuse away lah. Diffuse with the air. Okay, but if you have the closed system, the vapor molecule which leave the surface cannot escape from the system. So maksudnya, if you have closed system, so the vapor molecule could not escape the system even though they dah change to vapor. Okay. So what happened is, they will remain in the container and in contact with the surface of the liquid. This vapor molecule, they will be vaporized. Okay, so from the surface of the liquid, dia akan change to vapor molecule. And this vapor molecule, they will move in constant random motion. And it will continually strike the wall of the container. Next, it will strike and hit the other molecules. And it can also hit the surface of the liquid molecule. So every time the vapor molecule hit the wall of the container, so what happen is pressure akan terhasil. So the pressure exerted by the vapor molecule, we call it as vapor pressure. Liquids with weak intermolecular forces, we call it as volatile, means mudah meruap. And this volatile liquid will have higher vapor pressure. So maksudnya, if you give a little bit amount of heat ataupun kita bagi increasekan the temperature sikit, so this volatile liquid dia akan easily vaporize because of this weak intermolecular forces. So contohnya liquids yang easily vaporize adalah alcohol and so on lah. Okay, so let's have a look at intermolecular forces between these two organic compounds. We have here dimethyl ether and ethanol. So we already learned intermolecular forces. You have hydrogen bond. Hydrogen bond is stronger compared to dipole-dipole and stronger than London dispersion forces. Okay, so for molecule that has hydrogen bond, mean it will have stronger IMF ataupun strongest if you compare between these three lah. Okay, this is the strongest. Okay, so if you can see dimethyl ether tak boleh ada, there's no hydrogen bond. And syarat untuk hydrogen bond mesti hydrogen that bonded to F ataupun O ataupun N, nitrogen atom. Okay, so for ethanol you have hydrogen that bonded to oxygen. So means ethanol boleh form hydrogen bond. Therefore, intermolecular forces in ethanol is stronger compared to in ether. Therefore, the conclusion is less energy is needed to overcome the intermolecular forces that is weak in this dimethyl ether, okay, compared to ethanol. Therefore, dimethyl ether is more volatile compared to ethanol. It will has higher vapor pressure. Next, let's have a look at boiling point. So, boiling point is the temperature at which vapor pressure of the liquid is equal to the external atmospheric pressure, or in simple word we can say the temperature. Okay, so boiling point is takat didih, the temperature at which the liquid start to convert to vapor. Okay, so the change from liquid state to gaseous state occurs at the surface and inner part of the liquid. Therefore, temperature will remain constant during the boiling process even though the heat is supplied. Maksudnya dia dah capai dia punya level ataupun the boiling point. Boiling process will happen at specific temperature and also pressure. So contohnya boiling point for ethanol. Ethanol is 78 degree Celsius, and for boiling point untuk ether tadi, diethyl ether, it is around 38 degree Celsius. Okay, so each of them dia ada dia punya boiling point. Each of the molecule of water boiling pointnya adalah 100 degree Celsius. Let's have a look at the comparison between vaporization and boiling. So for vaporization, it is the change of state from liquid to vapor, but it only happens at the surface of the liquid. But it can happen at any temperature and any pressure. And the difference between boiling, okay, the similarities is dia adalah change from liquid to vapor, but it can happen in inner surface, maksudnya dekat surface ataupun dekat bahagian inner of the liquid. The second differences is it only happen at certain temperature which the vapor pressure is equal to the atmospheric pressure, and the temperature is called as boiling point. So in conclusion, strong intermolecular forces between the molecule will lead to higher boiling point. Thus, we say that liquid will be difficult to become vapor molecule. Thus, it is less volatile. Vapor pressure will also become low. But for weak intermolecular forces, it will lead to lower boiling point and the liquid will be easy to become vapor molecule. Therefore, we said that liquid will have higher volatility and it will result to higher vapor pressure.